So, day 3, subsets, intersections, and unions. So, in the universal set of numbers from 1 to 20, that's what we're starting with. Our overall set's 1 to 20. There are many subsets. List of numbers included in each one. Numbers less than 7. And be careful, this is less than, not less than or equal. So that's the numbers 1, 2, 3, 4, 5, and 6. Stop. If it said less than or equal, we would put 7. But it's just numbers less than 7. Even numbers. 2, 4, 6, 8, 10, 12, 14, 16, 18, and 20. Odd numbers? Well, all the other ones. 1, 3, 5, 7, 9, 11, 13, 15, 17, and 19. Hit pause if you need to. Multiples of 3. So starting with 3, 6, 9, 12, 15, 18, stop. Because the next one after that, oops, I wrote 18 instead of 15. After that is 21, and that's bigger. Numbers greater than 20. There are none. Okay? If it said greater than or equal, only number there would be 20. What numbers are in both sets A and E? So we need to look back at A and E. That's these two right here. What numbers are in both sets of A and E? So less than 7 and even. Well, that would be 2, 4, and 6. And that symbol, the arch, means the intersection. It's like an and. What numbers are in either O or M? So we go back and look at our list. O or M. Either one. Odd numbers or multiples of 3. So basically, 3 is already in both. 6 is not. 9 is. So basically we want the even numbers also. So 6, 12, and 18. So again, that was odd and any extra multiples of 3. So or means either one. We'll take either one. So we have 1, 3, 5, 6, which is the multiples, 7, 9, which is in both, 11, 12, which is a multiple of 3, 13, 15, which is in both, 17, and 18. So that has either or. So that's your odd numbers, 1, 3, 5, 7, 9, 11, 13, 15, 17, 19. Along with the odd numbers. Multiples of 3. 3, which is in both. 6, which is new. 9 in both. 12, new. 15 is in both. 18 is new. So again, odd numbers and multiples of 3. Either one of them. So, what about E and M? So, even numbers and multiples of 3. So, which ones are in both E and M? So we're looking for even numbers that are also multiples of 3. So that would be 6, 12, and 18. Now how about A or M? Now A is the numbers less than 7. So again, that's your 1, 2, 3, 4, 5, and 6. M is the multiples of 3. 3, 6, 9, 12, 15, 18. And we're looking for either one. And we just won't write them both. So that's going to be 1, 2, 3, which is in both. 4, 5, 6, which is in both. Along with 9, 12, 15, and 18. And then we're going to look at E and O. So E is the even numbers, and O is the odd numbers. So which numbers are in both sets, even and odd? There are none. These two sets are what are called mutually exclusive, because they do not share anything. They have nothing in common. One is odd, one is even. They don't agree on anything. All right, a Venn diagram. We're going to use numbers 5 through 16. Okay? And A is going to be the numbers greater than 10. So again, starting above 10, 11, 12, 13, 14, 15, and 16. The even numbers are going to be 6, 8, 10, 12, 14, and 16. What are in A and B? 12, 14, and 16. Where would those be in the Venn diagram? That will be in the middle, or the overlap. List any numbers in the universal set that are not in either A or B. Okay? Well, that would be 5, 7, 9. Okay, because 6 is up there, 8 is up there, and then 10 through 16 is up there. Where will we put these in the Venn diagram? Outside the circles. So, they're horrible circles. And we usually go A and B. Now, what numbers do we say are going to go in the middle? 12, 14, and 16. A is going to be 11, 13, 15. It doesn't matter where you put them. Now, if you look at A, there's 11, 12, 13, 14, 15, 16. Now B, 6, 8, 10. Now, does B have 6, 8, 10, 12, 14, 16? Yes, it does. And in the middle is the overlap. And on the outside of the circles, you can put them anywhere, are the numbers 5, 7, and 9. Now let's check. Are all the numbers between 5 and 16 covered? 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Yes, they are. Now, probability. What's the probability of A? Well, how many numbers are in A? 1, 2, 3, 4, 5, 6. Out of how many numbers are there total? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. What about the probability of B? What numbers are in B? 1, 2, 3, 4, 5, 6. Also out of 12. And how many are in the middle? 3 out of 12. And it says shade B. That's B. Okay? That is circle B. Everything in B. All right. You're picking marbles out of the bag shown below. List the sample space. Okay? Now, what is this 4R, 4W? Well, that's 4, red 4, and white 4. Okay? What else is there? Well, there's a number 1, and it's white. There's also 2, that's white. There's a 3, that's red. We already got the 4s. There's 5 white and 5 red to distinguish. There are no 6s. There's no 7s. There's an 8 that's white and an 8 that's red. And there's a 9 that's white. Those are different possibilities. Now, what are our red possibilities? Well, there's a 4 that's red. We said there's a 3 that's red. There's a 5 red, and there's an 8 that's red. What about our white? Well, there's a 9. There's also 1, 2, 4, 5, and 8. Right? Let's double check that. There's a 1, 2, 4, 5, 8, and 9. I missed the 9. Oh, that's what one that was given to us. Yeah. Now, draw a Venn diagram showing set U, R, and W. U is the universal, so we're going to have red and white. Red and white. Now, what numbers are in red and white? 4. There's red and white 4s. There's red and white 5s. And there's red and white 8s. Is there anything else that is red and white? Look carefully. It's very easy to miss stuff. Okay, now what's just red? Well, there's a 3. There's no white 3. And that's it. 3, 4, 5, 8's the reds. Now what's white that is not red? Well, we have a 1. We have a 2. There's no 3. 4 and 5 are in both. 8's both. 9 is white. Okay, so before we do this, how many marbles are in the bag? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's 10 marbles in the bag. Always good to know that. So, what is the probability of getting just a red marble? There's 4 red marbles out of 10. White, 1, 2, 3 marbles out of 10. Red and white, that's the middle. That's 3 out of 10. Now, red or white, doesn't matter which one. There's 1, 2, 3, 4, 5, 6, 7 out of 10. And then it says, shade the probability of a red or a white. So, that is all of this. Because it doesn't matter, red or white. All right, last one. In this bag of marbles, some sets overlap, intersect. If they do not share any items, then it's called mutually exclusive. We already talked about that. So let's look at this. Are set O and set E mutually exclusive? Is there any overlap? Well, do you see anything in both bags? Yes, they are, because there's no overlap there. Now, E is even numbers. We have 2 that's white, 4 that's white, 8 that's white, 4 red, and 8 red. That's E for even. Now, red marbles, what do we have? Well, we have 3, 4, 5, and 8. Those are our red marbles. Do they share any marbles? Well, yes. 4 and 8. Are any marbles not in either set? Well, yes. That would be 3 and 5. Wait a minute. Hold on. Sorry, I read that wrong. So we have our evens, which are all these. And then we have our reds, which include those. So what are not in either set? That would be 1 white, 5 white, and 9 white. Are sets E and R mutually exclusive? Well, that would be a no, because they do have some overlap of 4 and 8. So we're going to do these two right here in a diagram. So here's E, and here's R. So the evens are 2 white, 4 white, 8 white, 4 red right here, and 8 red right here. Those are the overlap. And the other reds are 3 red and 5 red. And numbers that are not in either one of them would be the 1 white, 5 white, and 9 white. Now, what's the probability of an even? Well, there's 1, 2, 3, 4, 5 evens out of 1, 2, 3, 4, 5, 6, 7, 8, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Same number as before. Probability of a red. There's 1, 2, 3, 4 out of 10. Even and red, 2 out of 10. That's in the middle. And shade, even and red. So even and red is this piece right here in the middle. And that's it.